Hey guys, what's good? Today back with another circuit and back to analog circuits. So today's experiment is a binary weighted DAC or digital to analog converter, and this is a 4-bit one. And yeah, so as it says in the name, binary weighted DAC, it uses R only resistors. So all the resistors are weighted. That means they have to be in a specific ratio, like double, 4 times, 8 times. That's generally what they do. So yeah, this is the circuit I've rigged up here. And before we get into the mess of this circuit here, the wiring and all of that, let me just go to the circuit for a second. Okay, so we have the circuit here as usual in multisim. So pretty simple circuit, and this is a op amp based circuit. So let's see what is going on here basically. So this is the weighted, you can say weighted resistors here. We have 1k, 2k, 4k and 8k. So you can see they're double, double, double. So that is the weighted part of it. And all of them are given to this 5 volt through tactile switches. And currently here I'm using tactile switches, but actually when you use a DAC it would be from a microcontroller or so all of it would be all digital directly going, so there won't be any mechanical switches involved, but it's just for demonstration so we get an understanding of it. So yeah, this is the 5 volt which is going to be our input, which is our high, which represents digital high, and ground, which is digital low. So all of them go through these switches here, and yeah, that goes into a op amp to the inverting terminal, and this is basically acting as a summing amplifier, inverting summing amplifier to be specific. So all of these resistors here, and there is a unity gain. So the lowest resistor here is 1k, so we use 1k as the feedback resistor here. Non-inverting terminal grounded, and yeah, we are powering the op amp with plus 12 and minus 12, plus minus 12 volts, and we do need a dual supply because since it's in the inverting configuration, you cannot go by with giving VE as ground, so we definitely need a dual supply. And this would give us a inverted output as it says in the name, so it would give a negative voltage. But so just for understanding, I've given here inverter and inverting amplifier, and there's no amplification as such, since again same input resistor 10k and in a feedback, so it's unity gain, same thing, but it'll just act as an inverter, and whatever negative voltage you get here, it's going to give that in positive. And same thing, and since it's in the same package, I'll be using the TL072 uh, JFET based op amp. It's from TI Texas Instruments. So yeah, that's a nice family. It's a dual op amp. This package, it has 8 pins. So yeah, so within one package we can have two op amps. So a second one is an inverter, and yeah, just put a multimeter here to check the analog output. So you give the digital output here, and this is the MSB, and this is the LSB. So it starts from here. So if you count the position, 2 cube, 2 square, 2 power 1, 2 power 0. So 8, 4, 2, 1 if you talk in binary language. So yeah, this is the MSB, this is the LSB. You get the digital input here, and you're gonna get the analog output here. So yeah, I hope the circuit was clear. Now let's go back to the rig. Yeah, so now we're back to the circuit, and now that we looked at the circuit diagram, you'll most likely understand it, but nevertheless, let me explain it once, just go through it. So these are the 4 tactile switches I was talking about. All of them, one end is connected to 5 volts here, and the other end and other resistors, the weighted resistors, and you'll think why are there so many, and they're just supposed to be 4. But yeah, ideally yes, but practically this is the 1k which we have single, 2k which is also single, but 4k, if I added 2k and 2k we would get 4k, but I checked the resistance on the meter and it was slightly below 4k, was around 3.9, so I added 100 ohm in series. So 3, or when you put the 3 of them in series, we get almost exact 4k. So we do need precision in this as much as we can. That's why I've tried to use 1% tolerance resistors here. So yeah, this is the 4k, and last but not least, same thing, we're supposed to have 8k, and yeah, this what I've done here is there's a 6.8k, there's a 1k that should give you 7.8, and I believe this is a 330 ohm resistor, and yeah, that should give us slightly over 8k, but yeah, when you check the meter, this comes to around exact 8k. So yeah, that is nice. So yeah, these are our weighted resistors, 8, 4, 2, 1, MSB, LSB. So yeah, the rest of it, yeah, here is the op amp. I don't know if you can see, I don't think. Yeah, okay, so this is the TL072. The output of all of these is going to this common rail here as shown. One end 5 volt, other end common rail. That common rail goes to the inverting input. The non-inverting is grounded, and just to get that inverter through a 10k, the output of this first op amp goes to the inverting of the second, and as always the non-inverting is grounded, and same 10k for unity gain to the output, and that is the output we're going to be seeing on this voltmeter here. Yeah, voltmeter here. So and for voltages, yeah, plus 12 and minus 12, there's a dual supply situation going here. This is the one of the power supplies, and this is the second power supply. And for the digital input, I'm giving the 5 volts through this 7805 classic linear regulator, and that is getting its power from 12 volt adapter here. So yeah, there is a lot of part, three different sources here going on, and that's why we need a extender. But yeah, ignore the mess. uh, so yeah, now let's go to the demonstration. Let me just switch the circuit on. Okay, so as you can see, currently we are at 0, nothing much is going on. Let me switch on the light. Yeah, so yeah, this is the sample table. This is how it's supposed to look. I'll just show you a few readings. So first 0, no input currently, which is yes. Now we're gonna give the LSB, which is digital 1. So I'll give 1 here, and yeah, we get 0.62 volts, and yeah, that's pretty close to this. Now keep in mind the same thing here, they're given minus, but I've used the inverter, so it's going to be plus. And let's try 2, which is here. So if I press this, we get 1.23, 1.25. Yeah, pretty close. And next we can try 3, which is both of them 1 1, and yeah, we get 1.867, and yeah, that's pretty close to the 1.875. And let's try 4 2. This is 4, and 2.54, and yeah, 2.5. That's good. And yeah, so I checked all of them, they're all pretty close to this. It works well. And just an anomaly or learning which I learned through this, and I took some time to figure it out. But yeah, let's go to this 14, which is 1110. So 14, which is basically these three, I'll press them here, and you can see we get 8.65 around, which is yeah, somewhat close to what we're supposed to get. Fine, great. Now last one is 15, and the full scale output should be around 9.3, right? So let me press all four of them, 2 3, and now I'll press the fourth one too here. Sorry, a little tough to press. And you can see here I've pressed all four of them, but our output is still 8.65, which is puzzling because that is not the full scale output, right? That is same as 14. So the problem here lies in the swing of the op amp, which is one of the non-linearities we face in all op amps. Since this is not a rail to rail op amp, this is a standard JFET based high slew rate op amp. So this cannot, you give here hypothetically plus 12 and minus 12, you expect it to go to plus 12 max and minus 12, but that is not how op amps work. They have these non-linearities, as I said, so it cannot swing to the exact output. It's going to have some cutoff. So it looks like this thing is not able to swing, even though technically it should. It's not very 9.3 is not very close to 12 volts. It should swing, but for whatever reason it is not swinging. So what I did was, this is our negative supply, right? So let's just try and bump this up to 13 volts, right? Okay, slightly above 13 it went. Okay, let's go. Yeah, 13. So now basically our plus VCC is still the same, plus 12, around 12.2 from this supply, but our minus is around 13, which is increased. Now let me do the same thing. 1 2 3, and yeah, press the fourth one. And 1 second, let me just hold it in this hand. Yeah, 1 2 3, and the fourth one, and you can see that we have gone to 9.34, which was previously not going. Yeah, let me just, yeah, a little tough to press, but yeah, 9.34, and you can see that is close to, almost exactly close to this. So this is a important lesson which we can learn from this about the rail to rail output of the op amp. And now that we increased this supply voltage here, we got the proper output. So that's an interesting thing to keep in mind. But yeah, that was the demonstration. I hope you liked it. Bye.